Hello again to everybody. So let's continue with the discussion on the conic section. And this is now the third type of conic, and this is for the ellipse. And as I have mentioned before, our conics will always fall under the second degree equation. So for the circle, we have the xy term is missing, a is equal to c. For the parabola, xy term is missing. There's only one squared term, so either x squared is given or y squared is given. Now for the ellipse, same thing will happen. The term xy is missing, and this time we will be considering the condition that a will not be equal to c, like for the circle, and another thing, a and c must have like signs. So if A is positive, we expect that C is also positive. If A is negative, C will also be negative. In this diagram, we will find that the ellipse is this one. So we expect that the shape of an ellipse is an oval shape. Okay. And the ellipse was obtained by considering a circular cone and passing a plane that will not be parallel to the base and at the same time the plane not cutting the base. Okay, and under the ellipse, so sabi nga natin, the standard form, there will be two squared terms, xy is missing, the coefficients of the squared terms will be of like signs and their numerical coefficients are not equal. We also have our standard forms. I will not be giving the standard form anymore if the center, that's one part of the ellipse, is at the origin. Let me just give the standard forms. Anyway, I'll be explaining this further later on. Uh, so we have the first one, x minus h, the quantity squared, all over a squared, plus y minus k, the quantity squared over b squared is equal to 1. So here we are given the condition that a is always greater than b. Again, hk will be our center. Then the major axis, which will be explained later on, kung alin yung major axis, will be parallel to the x-axis. Okay, but if the center of the ellipse is at the origin, the major axis will be the x-axis. On the other hand, y minus k, the quantity squared over a squared plus x minus h, the quantity squared over b squared is equal to 1. Again, a is greater than b. HK, center of the ellipse, and this time the major axis is parallel to the y-axis. And these equations are actually obtained by reducing the general form of the ellipse. And if you will look at our pattern for the circle, we have the general form, we have reduced it to the standard form. Similarly, for the parabola, we had the general form, reduce it to the standard form. So, ganun din for our ellipse. We have the general form will be reduced to the standard form. Okay. Now, regarding the parts of the ellipse, we have some important parts of the ellipse. We have the following parts of the ellipse. We have C, which is called the center. And according to this standard form, we have the center is at 8. And then we will have also our A1, A2, B1, and B2. What are these? These are the vertices of our ellipse. Okay. Wherein, if we get, let me explain that, center to A1 will be equal to center to A2. and the distance from center to A1, A2 is equal to A. On the other hand, center to B1, center to B2 is equal to B. If you will notice, these values can be obtained from the standard form. We have the denominator a squared, b squared. So if you extract the square root of this, you get a. If you extract the square root of b squared, you get b. And then from there, we also have our f and f1. F and f1 will now be called our foci, plural for focus. And then what do we need to remember there? Center to focus is the same as center to focus 1. And the distance of this is AE, where AE will have the value square root of A squared minus B squared. So we don't have time to derive all of this. We have very limited time, but anyway, I'll just go directly to how we compute values. Pero maganda nga sana kung na-derive pa natin ito. Okay? So you have there, distance from center to focus is AE. And then we have also Q, Q prime, Q1, Q1 prime. These are ends of our latera recta. Latera recta, plural for latus rectum. Isn't it for the parabola, we have encountered the latus rectum also. So here, if we will label, we have F to Q, F to Q1, pareho lang siya sa F1 to F1 to Q prime, or Q1, I mean Q1 prime, and F1 to Q prime. And the distance will be, that's F to Q is B squared over A. So you will notice that the values that the values that we need to obtain here are all coming from the standard form. We have the values of A and B. Okay, and then for the ellipse, we will have two directrices. We have DD prime and D1 prime. These are our directrices. And the directrices, we have the distance center to directrix DD prime and center to the other directrix D1 prime will have a value A over E. So the distance is A over E. Okay, so there you have the parts. Now, when we will be considering uh, the diagram for this one, let me just include a, I think we need a Cartesian plane. Let me just copy this. Okay, so if we want now to draw our our ellipse. So for example, our ellipse is having its center at HK, center, let's say at HK, where is the pen there? So let's say, let me just place it anywhere here. So let's say that's the center HK. Okay, that's the first thing that we can consider. So if let's say we are considering the standard form x minus h, the quantity squared over a squared, plus y minus k, the quantity squared over b squared equals 1. So this is our ellipse with center at HK, major axis parallel to the x-axis. So the next thing that we will consider is our major axis. So let's say that's our A1, that's our A2. Distance from center to A1 is A. Distance from center to A2 is also equal to A. Okay? So connect, if we now connect uh, A1 and A2 together, Okay, so let's just draw that line. Okay, so that line will now be our line passing through, or that line will now be our line where we find our major axis A1, A2. Okay, and then if we also draw a line that will pass through the center this time, this direction, parallel to the y-axis, that will now be where we will find our minor axis, and let's label where our minor axis will be. So let's say this is now where our B1 is, B1, and then let's say our B2 is somewhere here, and then the distance from center to B is small b, okay? Center to B2 is also B. So if you connect B1 to B2, that's our minor axis. So why is it called major axis and minor axis? In the sense that major is longer than the minor. That's why A is always greater than B. And then from there, you have two foci. So foci will always be located on the major axis, and it will always be nearer to the center. So this is now F, and then let's say this is F1. Then center to F will have distance AE, where we have AE is uh, the square root of A squared minus B squared. And then if you now draw a line passing through F, uh, parallel to your minor axis, draw another line passing through, wait, let me fix that. Uh-huh. For a while, I pressed the wrong key. Okay. Anyway, as I was mentioning earlier,